Okay, so in this video, we're going to continue our review of part 2 of the final. So this is the second part of our review of part 2. And we're going to start off with quiz 10, where we were required to, and this is completely a typo, where we were required to factor things of the form ax squared plus bx plus c. And if you're wondering what this whole thing means when a is 1, that just means you have 3 terms here, 3 terms in all of these. And in our 3 terms, always the x squared is equal to 1, or if you take out the GCF, the x squared will be equal to 1. I don't think we have any GCF situations going on. Strictly, all of our x squareds, the coefficients, are equal to 1. All right, so in order to factor these, you do it the same way every single time. You're going to look for 2 numbers that multiply to get your last number. That's if it's arranged in order. So it multiplies to get your C, and it adds to get your B. And by B, I mean the number in front of, or the coefficient of our x. By C, I mean the constant. That means the number without an x. So 2 numbers that multiply to get the 18 in this case and add to get 11. And in this case, our 2 numbers would be, I would say 9 and 2, because plus 9 or positive 9 and positive 2 does multiply to get 18 and add to get 11. And you're going to separate x squared into its factors, so we just always have an x here and x here. All right, once you know how to do these, they get pretty fast. So multiply to get 25 and add to get 10. Our 2 numbers are 5 and 5. Yes, the numbers can be the same. So x plus 5, and that's supposed to be a parenthesis, and x plus 5. All right, and same idea here, but now we're going to have to pay close attention to the sign. So they have to multiply, or 2 numbers have to multiply to get positive 15 and add to get negative 8. So again, we're paying close attention to the sign, and our 2 numbers that multiply to get positive 15 but add to get negative 8 is negative 5, or are negative 5 and negative 3. And of course, we're separating the x into its 2 factors. Again, we're paying close attention to the sign. They have to multiply to give you negative 8, but add to give you positive 2. So 2 numbers that multiply to give you negative 8 and add to give you positive 2 are plus 4 and minus 2. All right, and then we go ahead and we keep doing that. So 2 numbers that multiply to get 9 and add to get 10. 9 and 1, that one's not too bad. X plus 9, x plus 1. Okay. Now this one looks a little tricky. A lot of people make a mistake on this one. But it's the same idea. 2 numbers that multiply to get negative 30 and add to give you negative 1. There's an invisible 1 right there. So our 2 numbers that multiply to give you negative 30 and add to give you negative 1 are minus 6, so negative 6, and positive 5. And of course, we separate the x's like that and that. All right, and just a couple more. 2 numbers that multiply to get 40, add to get negative 13. Those 2 numbers are negative 8 and negative 5. So x minus 8 and x minus 5. And 2 numbers that multiply to get negative 2 and add to get negative 1, that invisible 1 right there. So our 2 numbers are negative 2 and positive 1. So it factors to x minus 2. And x plus 1. All right, and that's that quiz. And now we can move forward to the difference of 2 squares. Funny thing about the difference of 2 squares, people tend to think it's the hardest one when it's actually the easiest one once you remember it exists. So it's exactly what it sounds like when it says a difference. That means there's going to be a minus sign, minus sign, minus sign. Everywhere on this page is just minus, 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 because it's a difference of 2 squares. So that means you're actually going to have 2 perfect squares in order to factor in this way. So if you have 2 perfect squares, and there is a subtraction sign, it's always factored with one positive and one negative. Does not matter which one is in which parenthesis, but I like to write my plus sign first. Doesn't matter though. And then you take the square root of the first term, you put it here, you put it there. You take the square root of the next term, you put it here, and you put it here, and we factor the difference of two perfect squares. Now, the thing about this page though, not everything is two perfect squares right away, but many of them are. So when we get to one that's not two perfect squares, you will see how to approach it slightly differently. All right, but 16x squared is a perfect square, and so is 49. So we can go ahead, put our parentheses down, make sure we have two different signs. Square root of 16x squared is 4x, and make sure you don't forget that x. And the square root of 49 is 7, and it's going to be the same thing in both parentheses other than the sign, so we put those there and we're done. And we go ahead and we do the same thing, perfect square here, perfect square there. So we go ahead and square, well, different signs, so plus in one, minus in the other. Square root of 25x squared is 5x, so that goes in both. Square root of 49y squared, and don't forget the y, is 7y. All right, so now a lot of people, by the time they do 3 of these, they're like, everything's a perfect square, life is all good, but everything is not a perfect square, because 180 certainly is not a perfect square, and neither is 5. Which means that there is something up, something fishy. Well, in this case, we have to look to see, is there a greatest common factor? And there is. 5 can actually go into 180p squared as well as into 5. So we can go ahead and factor out the 5. So when we factor out the 5, so we write that on the outside, and I'm not going to attempt to factor the difference of two squares yet. I'm just dividing everything by 5. So here we have, when we divide this by 5, we get 36, 36p squared minus, divide that by 5, we get 1. And look at the magic that has happened. This is now a perfect square, and so is this. So now we can do difference of two squares. So I set up my two parentheses, make sure the signs in them are different. So plus in one, minus in the other. The square root of 36p squared is 6p. We put that in both. No, forgot the 6. That's a 6p. And then the square root of 1 is 1, so we put that in both. And we've now factored it. That 5 helped us quite a lot. Now, if you look at this, it's also not two perfect squares. 75 is not a perfect square, and neither is 3. But there is, again, a greatest common factor. So we take out the greatest common factor, which is 3 in this case, divide everything by 3. So 3, that divided by 3 gives you t squared, and that divided by 3 gives you minus 25. And we can go ahead and we can do the difference of two squares, because now it's a perfect square and a perfect square. So we have a plus sign, a minus sign, and the square root of t squared is t. We put that here and here. Square root of 25 is 5. We put that here and here. And it was done. All right, so here we look like we would have the difference of two squares again, because that is not a perfect square and neither is this. So we go ahead and we try to figure out what goes into both. I believe 5 goes into both. So then 5 into 125 gives us 25, and we have r squared. Oh boy, there we go. Minus 4s squared. Now we have two perfect squares, so we can go ahead, set up for two sets of parentheses, plus in one, minus in another, and square root of 25r squared is 5r, and we have the same thing here, 5r. The square root of 4s squared is 2s, so that goes here, and 2s, so that goes there. And that's how the difference of two squares work. So hopefully you'll remember it, because it's not hard when you remember it, but when you don't remember it, it's close to impossible. All right, so the whole purpose of factoring is that we could start solving. So I think we're going to get through this video and then we're going to call it a day and maybe do the rest in one final video, or maybe two, we'll see. All right, so when you're trying to factor and solve, the first thing you always want to do is make sure your quadratic is equal to 0. Then you have to factor. So this question 1, you actually already did 2 of the main steps. After you've factored, so now it's in factored form for number 1, then you have to remember that whenever you're multiplying 2 terms and the answer is 0, that means one of the terms must be 0. So either 3x plus 5 is 0, or 2x minus 3 is 0. So we can go ahead and solve this regular linear equation. We can go ahead and take 5 from both sides here, and we get that 3x is equal to 5, negative 5. And x, dividing both sides by 3, is equal to negative 5 over 3. And we go ahead and do the same thing for the second side. We're isolating the x, so we can go ahead and add 3 to both sides. And we get that 2x is equal to 3. And we can divide both sides by 2, and we get that x is equal to 3 divided by 2. All right, well, the first one was there to spoil us. After that, we actually do have to make everything else equal to 0, or factor, or something more than we just did. So here we have x squared is equal to this. I like to have my x squared positive. It's not a must, but it's much easier in my opinion. So I'm going to take this, I'm going to add to that side, I'm going to take this, I'm going to also add it to that side. And so I get that x squared plus 10x plus 25, oops, is equal to 0. All right, and that's 10, it doesn't look like 1. All right, so two numbers that multiply to get 25 and add to get 10, those two numbers are 5 and 5, so we have x plus 5 times x plus 5 equals 0. And again, remembering that either that has to be 0 or that has to be 0, that means that x is equal to negative 5 or negative 5. But that's the same thing, and you only have to write it once. All right, if you wrote it twice, it wouldn't be a big deal. Okay, so now, hopefully you remember the difference of two squares, because that's a perfect square, and so is that. So to factor it, once you remember that, pretty easy. Just remember that the signs have to be opposite, so I'll go ahead and put those in first. We have a plus in one, a minus in the other. And then we take the square root of 9x squared, which is 3x. And that has to go in both parentheses. There we go. And we take the square root of 49, which is 7, and that goes in both parentheses. And so we get that that is equal to 0, which means that either that's equal to 0 or that's equal to 0. And I'm going to go ahead and solve this part pretty quickly, because you saw me take my time doing it up here, and you're just going to repeat the similar or same steps. All right, so in this case, x is negative 7 over 3. The pen is on its way out. And in this case, x is positive 7 over 3. That does not look like 7 over 3, but it is. Oh boy. All right, now for the next one, it is much harder. So we have 3x squared minus 8x minus 16 is 0. Now, if you are in my class, you've learned how to do this in two ways. You've learned how to do this using trial and error, and you've learned how to do this using the diamond box method. If you are not in my class, then maybe if you would like to follow what I'm about to do, you might want to watch the diamond box video because it's going to go pretty quickly here. All right, so in order to solve something like this, or in order to factor something like this, we first start off with the diamond. And in our diamond, we put b in the middle here. So -8. A times c goes down at the bottom. So that a times c, hold on. A times c should be -48. So 3 times -16, -48. And then we're looking for two numbers that multiply to get -48 and add to get -8. And those two numbers, if you think about it long enough, you should figure out the numbers are -12 and 4. All right. So once you have your diamond, time to create your box. So in your box, in the top left hand corner, you put our a value, which is 3. Bottom right, you put the c value, which is -16. And then these two values go anywhere over here. Doesn't matter which one goes where. I'll put -12 here. But I could have put 4. I'll put 4 here. All right, that's a 12, -12. All right. So now we look for the GCF of 3 and -12. And the GCF there is 3. 3 into 3 is 1. 3 into -12 is -4. And -1 times what number gives you 4? That should be 4. So now we can see that this should be 3x plus 4. And that's 1x minus 4. So it factors that way. So 3x. There is no way this pen is going to make it to the end of this video. We'll try. 3x. It just decided it was done. Plus 4. Okay. And x minus 4. So I will quickly finish this one question and then we will move on to the next video. Oh boy, sheesh. Okay, so that means that x is, and I might just have to say this without writing it, but x is -4/3. Definitely saying it without writing it. X is equal to -4/3, and x is equal to 4. So as far as continuing this quiz, I will do so in part 2C of our lessons. So stay tuned for the next part.